Hi, in this lesson I'm going to show you a solved problem, and this is on operations on functions, particularly the division of functions. Suppose that we have the following functions: f of x equals 4x over 3x minus 2 and g of x is equal to 1 over x. Find f over g of x. So the solution to this problem is, first we need to know that f over g of x means f over x over g of x, and this, from here we can see that all we need to do is to supply the expression for f of x and the expression for g of x. So that means f of x, so replacing that by the expression 4x over 3x minus 2 and g of x as 1 over x. So from here, we use the idea that whenever we divide expressions, particularly fractions, the best thing that you can do is, well, this is something that is taught in probably your class, is to multiply the reciprocal of 1 over x. Okay, so when you perform division, fraction by fraction, you multiply the numerator by the reciprocal of the denominator, and that is x over 1. So from here, we can proceed now. So from division to multiplication of the reciprocal, we multiply, so directly numerator to numerator and denominator to denominator. Now in some cases, there are expressions in which after flipping, we sometimes they call this flipping the denominator, there is something that you can cancel in the numerator and in the denominator. But in this case, as we can see, there are no common factors, so we can just simply go and directly multiply the expressions. So 4x times x, as we know, is 4x squared. 3x minus 2 times 1 is 3x minus 2. So there you go. The quotient f over g of x is equal to 4x squared over 3x minus 2. By the way, do not commit the mistake of canceling x and x here. You cannot do that because the 3x, the x in the 3x has a minus 2 and it should be taken as a group. You cannot just cancel x if x is within a given group. If you have 4x squared over 3x, then definitely you can simplify this into 4x over 3, but not on a 4x over 3x minus 2. You cannot just cancel this x and x there. This is not allowed. Okay, so that means we can leave the answer as 4x squared over 3x minus 2. Now let me show you one more example. Suppose f of x is 1 plus 1 over x and g of x is equal to x, and the goal is still f over g of x. So again, as we know from the first example, from the first solved problem, our f over g of x is the same as f of x rather, divided by or over g of x. So same idea, you get the corresponding expressions for the f of x and for the g of x. Now from here, there are many things that you can do. Unlike the first example, well, if we will follow the solution from the first problem, then we could proceed. I'll show you the first option. We can proceed by having 1 plus 1 over x. Note the division, this is the division, will be changed into multiplication. So I'm now introduce dot for the multiplication to avoid the confusion with the x, although in the first example I still use the x or the x symbol for the multiplication, but let's use the dot for the multiplication. So 1 plus 1 over x, the division becomes multiplication, and that you multiply the reciprocal of x, and the reciprocal of x is 1 over x. So this is times 1 over x. And then you distribute, because you have this some sort of a plus b times c, right? This is a, b, and c. So you distribute 1 over x times 1 expression times 1 will be the same expression. 1 over x times 1 over x. So you should know that 1 over x times 1 over x is 1 times 1, x times x, and that is x squared. So 1 over x squared. Now this can be the final answer, but if just in case the problem requires you to combine them as a single fraction, then you just use the LCD. The LCD is the x with the highest degree, and that is x squared. So how do you find the numerator? You divide x squared by x. X squared divided by x is like this, so which is simply x, right? So this is x. So x times 1 is x. Then x squared divided by x squared divided by x squared is 1. So times 1, so that's 1. So the other expression is x plus 1 over x squared. And that is by utilizing the idea that we learned from the first example. Now what is that other option that I was talking about? Okay, let's say we still have our f of x over g of x, and we have reached that part where we replace the corresponding expression. So another option is, instead of going straight to changing division to multiplication of the reciprocal of x, what we can do is to simplify the numerator. To simplify the numerator means you have to combine 1 and 1 over x as a single fraction. So working with that, 1 plus 1 over x, well, this could be easy if you think of 1 as x over x. Something divided by itself is equal to 1. So x over x plus 1 over x. See, this is x over x and this is 1 over x. So x over x plus 1 over x will be, so make sure you know your addition of fraction. When you add fraction, you just copy the common denominator, which is x, and then will the same denominator x, and then you have x plus the 1. So the numerator becomes x plus 1 over x, but don't forget you still have this over x. And from here you now do the flipping of the x, or the multiplication of the reciprocal of x. So that's times 1 over x. And then numerator to numerator, denominator to denominator, this is multiplication. So x plus 1 times 1 is x plus 1. X times x is x squared. And here you can see that the same expression was obtained. Okay, so both the first solution and the second solution should give the same answer. Okay, so it will be up to you which solution you will be using, so whichever you can understand. Okay, but if you know the two, then that would be better. Okay, so just to summarize what we have discussed in this video is that whenever you divide functions and the long division is really not required, okay, because there are some expressions that will require long division, and this will be happen in the case of polynomials of higher degrees. But if you have like a rational function and another rational function, or let's say another linear function, then all you have to do is to remember that when you are dividing a fraction, that is the same as multiplying by the reciprocal of the fraction, and then you just perform the multiplication. It should be the correct way of multiplying the expression, and you will be able to get the final answers to the problem. Okay, so I hope that you learned something from this video. This is this video focused on division of functions, and that didn't require any long division, and it's more of direct multiplication and simplifying the expression. Okay, so this is part of the solve problem series that I have been doing. So I hope that with these two examples you'll be able to work now on similar problems like this one. Okay, so that's all for this video. Thank you.